Hello everyone. The theme of our research is digital signature scheme. We will introduce three different algorithms and compare them with each other. Now let me to introduce the first digital signature algorithm, RSA. There are three steps in total to implement it in the RSA algorithm. The first step is to generate public key and private key. The algorithm is to select two distinct prime members. Then we just follow the process on the slide to calculate the result. The parameter E and D are the keys we want. For signing part, the sender first generates a random hashcode based on the message and then writes it to the power of E with module N, which is as same as describes the data with the sender's private key. After that, the sender sends the result of the calculation with M and N as a digital signature to the receiver. Then we move to the verification part. The receiver needs to use the same hashing algorithm and combine it with the sender's public key to calculate them like encrypting it. At this point, the receiver needs to compare the computed result with the hash code he received. If they are the same, the receiver knows that the sender is correct and the message has not been tampered by someone else. However, this algorithm also has some limitations. One of the most obvious problems is the slow process of generating public and private keys. In order to ensure security, the algorithm requires that the two numbers are chosen to be large enough and prime. Here is a way to determine prime numbers. Miller-Rabin function. It is based on Fermat-Little theorem. Therefore, if n pass 1 testing, then the probability that n is not a prime number is 25%. If 5 times testing is passed, then the probability that n is a prime number is 1990.1990%. The worst case is that n contains a smaller prime factor. In this function, 600 small prime numbers are used for testing, so the reliability is guaranteed. Now let my team Li Sheng to introduce his part.
Let me introduce the elliptic curve cryptography part. Elliptic curve cryptography is an approach to public key algorithm based on elliptic curve over finite fields. The technique was first proposed individually by Neil Koblitz and Victor Miller in 1985. The crucial property of an elliptic curve is that we can define a rule for adding 2 points which are on the curve to obtain a third point which is also on the curve. Next page. And then in terms of the key generation part, there are 5 steps to generate the public key. And after we do this step by step, and we can get the public key consists of E, P, N, and Q. Next page. As for signing process, the sender needs to choose a random integer key between 2 and n minus 2 firstly, and then follow the next 4 steps, and then they can get the signature consists of Y and S. Next page. In terms of the verification process, when the receiver receives the signature, they will know the value of Y and S. The verifier needs to follow the step to get the function R, and if the verifier could find the value of X which minus the coordinates of set R, and the results will equal to Y, they can accept the signature, else they need to reject the signature. Next page. As for the evaluation part, the main advantage ECC has over RSA is that basic operation in ECC is point addition, which is known to be computationally very expensive, and that's also why the ECC is more security than RSA. And as for efficiency, as we can see, the sign and verify process using elliptic curve cryptography is faster than RSA. That's all for me, and my teammates will introduce the next part.
Thanks for my teammate Shengyi. And my name is Xin Zhifeng. I will introduce the digital signature algorithm. Let's move on to the introduction part. The DSA algorithm works in the framework of the public key crypto systems. On the right side, the picture describes the processes of the DSA. Okay, let's look at the key generation process. We need to choose the N and L, P and Q to generate the X and Y, which are the private key and the public key. And let's move on to the signing process. We need to choose a randomly an integer key and to compute the R and the S, and RS is the signature with the message is sent to the receiver. Let's look at the verification process. The receiver need to use the signature and the message to get the verification parameter V. And if the V is equal to the R, then the message is valid. Okay, let's focus on the evaluation part. Compared to the RSA, whenever the receiver receives the invalid data and the valid data, the DSA has advantages on the signature part. Okay, that's all of our topic. Thank you for your attention. The next page is our reference. Thank you.